So for the next couple of days, we're going to concentrate on writing Lewis dot structures for covalent compounds. And in order to contrast that with what we've just learned about the other day, rather quickly, is ionic Lewis dot structures show you like that how the cation loses the electron and where the anion sticks that electron that it gains, and then how they come together as oppositely charged ions, and you're written in brackets and all that beautiful stuff, right? What we're going to do with covalent Lewis dot structures is show how atoms will share their electrons to achieve an octet. You might remember that when we defined bonding, right, it was either the electrostatic attraction between oppositely charged ions, or it was atoms sharing electrons in order to achieve 8 electrons in their outermost shell, in their valence shell. So with covalent Lewis dot structures, we're going to show how that can happen. Okay, so let's look at how we can draw Lewis dot structures using this method called the electron placement method. So we're going to use a sample molecule, HCl. And the first step, if you're going to place electrons, you need to know how many electrons you're dealing with. So the first step when trying to do a Lewis dot structure, which is show how these nonmetals are going to bond covalently to make everyone have an octet, okay, you count the number of valence electrons. So hydrogen has 1 valence electron. Okay, and chlorine has 7, so there are a total of 8 valence electrons. So if you're going to try to put a hydrogen together with a chlorine, there are what we call rules of thumb, and we're going to kind of scroll down and we're going to look at what the rules of thumb. And again, in this case, H and Cl have to come together side by side, but that's not always going to be the case. So you're going to use these rules of thumb. Again, we're going to scroll down and look at them to determine what would be what's called the central atom. And then we're going to build what's called the skeleton structure by bonding them together. So I'm going to scroll down to the rules of thumb right now. So the rules of thumb, the first rule of thumb says that hydrogen or halogens, and halogens can be fluorine, chlorine, bromine, iodine, acetane, whatever, all of these, and because they have the same valence electron structure, they will all bond the same way, and chemists often denote any or all of the halogens by the symbol X. Okay, so if you see like HX or NaX, that means like sodium bonded to any halogen, because they're all going to bond in a similar manner because they all have the same valence electrons. But anyway, if you have a hydrogen, if your molecule contains hydrogen or any of the halogens, they like to bond on what we call the outside or on the ends. They are not usually in the middle. In fact, hydrogen can never, ever, never, ever, never, say it with me, ever, never, hydrogen never is bonded in the center of anything. Sometimes halogens can do that, but it's rare. So if I have a halogen, I'm going to put it on the outside. On the other hand, if you have carbon in your molecule, like CO2, carbon likes to be in the center. And if for some reason you have more than one carbon, like C2H4, that molecule, the carbon prefers to bond to itself. So if I were going to arrange my carbons in a molecule, I'm going to put them in the middle. And I'm going to go through a few examples. You'll see these in action, these rules. Now, what if you don't have carbon or hydrogen or a halogen, but you have something like NO2? You see you have the molecule NO2. Well, that doesn't have a hydrogen, it doesn't have a halogen, and it doesn't have a carbon. what would go in the middle? What would be the center atom? Typically, the atom with the lower electronegativity would go in the center, and that, my friends, in this case would be nitrogen. I always say, if you had NO2, do you think it's going to bond like this? Like, no! Or is it going to bond like this? Oh no. Like, who is going to be in the center, right? Well, it's going to be, in this case, nitrogen in the center. Okay, so let's apply the second rule to HCl. Well, I'm going to write H because that's going to be on the end. And the halogen likes to also be on the end. And I'm going to bond them together by taking 2 of the 8 electrons, which I'm going to write in as dots, like I do with a Lewis dot structure, in the middle. This would be the skeleton structure for HCl. Again, this is a simple one. So after I place these 2 electrons in step 2, I started out with 8 electrons. How many electrons are left that still need to be placed? 6 electrons still need to be placed, don't they? And so what you do is you go to the outside atoms and you make sure they have an octet by adding electrons in pairs until you use them up, okay, if you can. So I'm going to go 1, 2, 3, 4, 5, 6. And then, oh, wait a minute, I've used all my electrons. So then I would look at step 4, which says, place any remaining electrons on the central atom. And in this case, I'm out of electrons, so I don't even need to do step 4. If you use up all your electrons in step 3, you are done. But let's say, and we're gonna go over an example where we do have to add electrons to a central atom, okay? But for now, we don't have to do step 4. Okay, so again, since we used up all of our electrons in step 3, we're going to take our structure here, and we don't have to do step 4, like I said, because there's no more electrons. What you're going to do is you're going to rewrite this. And when you're done, and any pair of electrons that are shared, see that shared pair? Those are shared electrons. You are going to write as a bond line. So those 2 shared electrons become a bond line. And then you're going to complete the Lewis dot structure by just copying down what chlorine had around it, you see? Kind of going back to these electrons here that were shared, that we turn into a bond line. The other terminology that we're going to use with Lewis dot structures would be for these electrons out here. I'll just cover it right now. So these are what we would call shared electrons. These out here are called unshared because they're not being shared, right? They're just on chlorine only. Sometimes they're called non-bonded because they're not in the bond. And this is the one I love because it's completely ridiculous. They are sometimes called lone pairs. Now that's an oxymoron if I ever heard one. Lone pair. How could you be alone if you're in a pair, right? But the point being, they're either called unshared electrons, lone pairs. Those are the 2 most common things that we call them, as opposed to shared electrons, which these electrons here that are shared are the ones that are going 1 for me, 1 for you, or whatever, 2 for me, 1 for you, whatever it is, right? Okay, so now we're going to go through the steps for OF2, oxygen difluoride, carbon dioxide, and carbon monoxide. So let's look at oxygen difluoride. The first step says, figure out how many valence electrons there are. You have to do this step. Sometimes students want to skip this step, but you have to do this step because otherwise you don't know how many electrons you're putting into the structure, right? It's just mandatory. So oxygen has 6, fluorine has 7, but there's 2 of them. So this guy has 14 plus 6, which is 20 total electrons you're going to have to place. Much more than the 8 electrons of HCl. So this is going to be a little, more electron placement. Okay, so of these guys, oxygen and fluorine, which one do I want to make my central atom and which one do I think is going to bond on the ends, gentlemen?
You probably want to make oxygen your central atom.
Yeah. Why is that?
Because it has less. There's only one.
There's only one of them, and sometimes it would be central. But what else? What? Given the rules of thumb, yeah, Jacob.
It has less electrons.
Not just less electrons. Yeah, Anshul.
Electronegativity.
The electronegativity is lower than fluorine. What else? What do we know about halogens?
Oh, I was going to say because it's
Yeah. Anyway, what do we know about halogens? Go ahead, Jack.
Halogens like to bond on the outside.
Yeah, so halogens like to bond on the outside, so that means that kind of sticks oxygen in the middle. But it's also correct, Anshul, it has a lower electronegativity. So chances are it's going to be in the center. So when I line up my elements to bond, I'm going to say FOF. I don't know. FOF. Okay. And I'm going to single bond each of them. So, okay. Okay, so that was like step 1, right? Now step 2 says, well, take the remaining electrons. There's 16 electrons remaining, and you can kind of keep track if you want. And you're going to put them on the outside atoms. 2 at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I added 12 more electrons, so there are 4 left. So these 4 electrons that are left over after we place the electrons make octet on the outer elements, you're going to take these and you're going to put them on the central atom. Oh, look at that. And now I have 0 electrons. And at this point, I want to make sure that every element has an octet. If they don't, then I might have to do the second part of step 4, which would be to double or triple share. Well, with all the shares, does this fluorine feel like it has 8 electrons? Yes. This fluorine feels like it has 8, and this oxygen feels like it has 8. You're done. This is the Lewis dot structure, except for one more thing. What do I need to do? Bond lines. So once you put the bond lines in, you have the F bonded to O, bonded to F, and you write in all of the unshared electrons that were there. So the only ones that you turn into the bond lines are the shared electrons. With me? All right. Okay, now let's do CO2. Okay, so we're going to do CO2. I'll kind of do it more toward the center here. So carbon has how many? 4. Each oxygen has 6. So there are 16 total electrons that I need to place. So which is going to go in the middle? Who's going to go in the middle? Carbon, because carbon likes to be in the middle. It also has a lower EN. So carbon would go in the middle, and the oxygens are going to go on the end. And I'm going to bond them together with the pairs of electrons. So I had 16, and now I still have to place 12. Are you got it? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, wait a minute, I've used up all my electrons. Now I'm on step 4. Well, there aren't any electrons to place on the central atom, so I think I'm done. However, now I have to do the octet check. Does oxygen think it has an octet? Yes. How about this oxygen? Ooh, how about the carbon? No. And so what you're going to do is this. You move in like that one, I think that one step said on the rules of thumb. You end up, you erase, you take electrons from the outer atom and you move them into the share. And then wherever to make an octet. Well, I did that, but carbon still only has 6. Now this oxygen still thinks it has 8. So then I would take this guy and in pairs move them from the end atoms, right, to the central atom. And you do that again in pairs. And now you're going to do your octet check. I can't say that without messing up. So does oxygen think it has 8? Yes. Does carbon think it has 8? Yes. Does this oxygen think it has 8? Yes. So we're going to write every shared pair gets a bond line. And then I'm going to write the unshared pairs here. Okay. And that is the final answer. These kind of bonds where you have a double share are called a double bond. Okay, carbon monoxide. Carbon has how many electrons? 4. Oxygen has 6. I need to place 10. Okay, so who would go in the middle? Well, there's just 2 elements here, so there's not really a middle, but for steps 1 through 4, where you have to figure out who's central and who's not central, who would be the central atom? Carbon. Okay. So I'm going to put carbon next to oxygen, and I'm going to single bond it. That's what you do from the beginning. You build your skeleton. The next step, so I'm down to 8 electrons. So I'm going to start, and I'm going to start on the what we would call the outer, the outer element, because we already said, well, carbon likes to be the central atom. So that takes care of 6 of them. I have 2 left. So those are going to be placed on the central atom. So now I'm in the middle of step 4. Does oxygen have an octet? Yes. Does carbon have an octet? No. So what you're going to do is you're going to move in pairs. I'm going to move 1 pair from oxygen to the central atom by bringing it into bond. So oxygen still has 8. Does carbon have 8 yet? No. So what do I need to do? Move another pair from the outside atom. So I'm going to move those. It doesn't matter which pair you move in. I'm going to move those in there. Now, does oxygen have 8? Yes. Does carbon have 8? Yeah. That, my friends, is a triple bond. Okay? And so we're going to rewrite this as carbon 3 bond lines, because for every shared set of electrons, you make a bond line. And then you leave the unshared pairs on the outside atoms. And so this would be the final answer for this, because again, we said carbon thinks it has 8 and oxygen thinks it has 8, and that's because they are sharing 3 sets of their electrons. It's kind of amazing, but this is what it is. Okay? So that's pretty much it. I think you guys now, you just have to, go through, the 13 challenges on the homework, right? Again, keep in mind the rules of thumb. Carbons like to be in the middle. They like to bond to themselves, right? And just follow all the rules. Halogens and hydrogens like to be on the outside. Follow the steps, and you should be able to do these, okay?